All right, let's talk about standard electrode potentials. So remember our analogy, we kind of have these electrons flowing down our little hill, our waterfall, our potential. And remember this difference between the two potentials is the cell potential. And in this case, we're specifically talking about standard state. So think about what standard state means. 25 degrees Celsius generally, 1 atmosphere of pressure, and 1 molar solution. The 1 molar solution is the most important part here. And so when we're talking about this height difference, we can measure the E cell. But we can't measure the individual heights. We can't say, oh, this individual piece has a, potential of 0. You can't do that. So, but not the height, which is the potential of the components individually. We can only measure them when we put them together in a cell. And so if we want to kind of compare values, we have to set an arbitrary 0. So this is kind of like temperature. Think about temperature. It's a unit of thermal energy. So does 0 degrees Celsius have 0 thermal energy? And the answer is no. 0 degrees Celsius is just when water freezes to ice, but you can definitely have less thermal energy than that. Even Fahrenheit, 0 Fahrenheit, is that 0 thermal energy? No. You can definitely have negative Fahrenheit. If you live on kind of colder places, you have that on a regular basis. The real 0 is Kelvin. And so the same thing here, we can't really find a real 0, so we just pick one thing to be a 0 and then have everything be relative to that. That way us scientists can communicate with one another. And so the arbitrary 0 that was chosen here is what's known as the standard hydrogen electrode, or SHE. So if you're reading kind of publications, they'll give you a potential of something and they'll say versus SHE, versus this standard 0. So I'm 1 volt above the standard 0. I'm 1 volt below the standard 0, that kind of thing. So the standard hydrogen electrode is an inert platinum electrode in 1 molar hydrochloric acid with 1 atmosphere of H2 gas bubbling through. And what's going to happen here is 2 H pluses, right? Our acid from HCl are going to interact with 2 electrons, and they're going to form a molecule of H2 gas. And we define this as a cathode, and we say this is 0.00 volts, and everything is relative to it. So here's just kind of a picture of it, right? You see it's a platinum electrode. You're going from H plus to H2 through reduction. And so what we can do is we can couple other reactions to it, right? The other half of the cell. And find the E of the electrodes. So for example, again, you can't measure the potential of one electrode by itself, but you can measure the potential of a cell. So since we set our hydrogen at 0 volts, we can put a little voltmeter. We measure this 0.337. Well, if this is 0, then this must be 0.337 volts. And so kind of one confusing thing that's going to come out of this is right here, and that its electrons are negative. And so they're attracted to positive charge, or a positive potential. So when we're thinking about our little diagram here, our height, our electrons flowing through, you have to kind of think about what this axis is. And since electrons want to go towards more positive, when you're talking about them going downhill, you're talking about them going towards a positive. And then the negative is on top. So kind of flipped axis of what you may expect, but it makes sense if you think about electrons and them being negative and attracted to a more positive charge. So electrons going towards a more positive potential is spontaneous, and electrons going towards a more negative potential is non-spontaneous, right? So that's not going to happen by itself. So again, just to reiterate, electrons flow from more positive or from more negative potentials towards more positive potentials.